These are notes from section 10.5, which is on hyperbolas. A hyperbola, first of all, the definition of a hyperbola is the set of points in a plane such that the difference between the distances from the point to two fixed points is a given constant k. Notice that's exactly the same as the definition of an ellipse, except now instead of the sum of the distances from the point to two fixed points, now it's the difference. The way a hyperbola looks, we do have a center. So we have the center of a hyperbola. We have two vertices, just like we do with ellipses. But instead of having co-vertices and drawing our ellipse around like that, what we'll have is we will have a couple of asymptotes that will wind up looking like this. And then the hyperbola will get close to the asymptote, touch the vertex, and then turn and get close to the other asymptote. Something that looks a little like that. We could have vertices that are up and down, and our hyperbola opens up and down. We could also have it where it opens to the left and to the right. Notice a hyperbola is also different than a parabola in that a parabola, as you get further and further away from the vertex here, the slope gets steeper and steeper and steeper. So if I went out over here and way up to where the parabola is, it would look almost vertical at some point. Whereas a hyperbola, instead of eventually curving up and getting steeper and steeper, it gets closer and closer to this asymptote, so it'll have more of a set slope. The equations look very familiar. They are exactly the same as the equation of an ellipse, except instead of a plus sign in between, we have a minus sign. So x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Or it's possible that the y's are the positive one and the x's are negative. Y minus k squared over a squared minus x minus h squared over b squared is equal to 1. If it looks like this, if the x's are squared, our hyperbola opens to the left and to the right. If the y's are the positive ones, so it's y squared minus x squared, these are the ones that open up and down. So this one over here would be in this format, y squared minus x squared. Notice the a squared is always the one that is positive. B squared is the one with the negative. A is the same thing as with an ellipse. It is the distance from the center to a vertex. B for an ellipse was distance from center to co-vertex. Notice we don't have co-vertices. The B value is actually going to help us figure out where these asymptotes are. So we are going to call it the distance from the center to the corner of the asymptote box. So B is going to be, if I have a point right here that's in line with the vertex, B is going to be this distance right here. That might not make a whole lot of sense right now. That's okay. We have a C value as well. Remember, we do have two foci. C is the same thing as it was with ellipses, distance from center to focus. Our two foci would be like right here and right here. Just like with a parabola, the hyperbola bends around each focus. There is another relationship between A, B, and C. Notice C is this distance right here, whereas B, distance from center to vertex, is only, A is only this distance right here. So C is bigger than A, so the equation can't be A squared equals B squared plus C squared. Instead, C is the bigger one. So for a hyperbola, C squared equals A squared plus B squared. All right, so let's take a look at one of these and see how to do it. This first one, we are given the equation of a hyperbola. We are asked to find the center, the vertices, the foci, and the asymptotes, as well as drawing a graph. We are given x minus 3 squared over 16 minus y plus 1 squared over 4 equals 1. The center is right in the formula. HK again, center is at 3, negative 1. 3, negative 1, there's the center. Square root of 16 is 4 under the x's, so I'm going to go left 4 and right 4. Because that is the positive one, those are our vertices. And I know that this hyperbola is going to open this way and this way. So those are our vertices. We can go ahead and list those. Our vertices are at negative 1, and at 3, 4, 5, 6, 7, negative 1. Let's get our foci. To get the foci, we know for a hyperbola that c squared is equal to a squared plus b squared. A squared is 16, b squared is 4. So c equals root 20 or 2 root 5. So I'm going to start at the center, and I need to go left and right 2 root 5 to get the foci. So my foci are at 3, going left and right 2 root 5, and the y value of that point would still be negative 1. Our foci should be located at 3 plus 2 root 5, negative 1, and 3 minus 2 root 5, negative 1. To finish the graph and to state the asymptotes, we need to use our b value. So we went left 4 and right 4. Those are our vertices. We would go up 2 and down 2. But instead of going up 2 and down 2 from right here, we're going to start at our vertex, go up 2 and down 2. Up 2 and down 2. And those points, we said earlier, the asymptote box, it looks like this. This point, and this point all line up in a line on the asymptote, as do this point, and this point. So we can sketch in our asymptotes right now. This one should look like that. Notice it passes through those 3 points. And this one looks like that guy there. We can finish drawing our graph. We need to go through our vertices. That is a vertex. That's the point where it turns and goes the other way. And stay close to the asymptote. It's got a little wiggle in it there, but this one close to the asymptote through the vertex, turn and go the other way. That one looks a little better. We are asked to write equations of the asymptotes. In order to write an equation of a line, I need a point and a slope. Both asymptotes pass through this vertex, or the center. So we are going to use that point. So I've got y minus y1 equals slope times x minus x1. And this slope is up 2 over 1, 2, 3, 4. Up 2 over 4. Or up 1 over 2. This one is down 2 over 4. So my slopes of the 2 lines, one is positive 1/2 and one is negative 1/2. And both hyperbola, or both asymptotes, cross through the center. So I'm using the center as the point. Let's try another one. State the center, the vertices, the foci, and the asymptotes, as well as drawing a graph of y squared minus the quantity x plus 3 squared over 25 equals 1. Center should be at -3, 0. Square root of 1 is 1 under the y's, so I go up 1 and down 1. Those are my vertices. -3, 1, and -3, -1. To get the foci, we want to use c squared equals a squared plus b squared. A is 1, b is 5, c squared is 26, so c is root 26. Because my vertices line up vertically, I need to go up and down to get my foci. So they start at the center, -3. The y value of the foci starts at 0, plus or minus root 26. To get the asymptotes, square root of 25 is 5 under the x's, so I'm going to go right 5 from each vertex and left 5 from each vertex. And I now have enough that I can sketch in my asymptotes. And that one's bad. With a straight edge, it's a little easier. There we go. And then we want to pass through the vertex and stay close to the asymptotes. So this hyperbola is going to look something like this. Goes through that vertex. Got a big old wide hyperbola. Through the vertex, turns, and then stays close to this other one. So first couple examples, we are asked to state the information and draw a graph. Example 3, we want to write an equation. Write an equation for the hyperbola. It gives us the foci as well as the vertices. Like with other conic sections, I think it's easiest if we sketch this stuff out. So we need a focus at 3, -3. Another one at 3, 7. We have vertices at 3, -1 and 3, 5. We should be able to find our center. Our center is right in the middle of all that at 3, 2. State the center and the asymptotes. So center is 3, 2. We know we have x -3 and y -2. We also know that this hyperbola is going to open up and down. So the y's need to be the positive one that comes first. Make sure we've got squared on both of those. Make sure we've got a minus in between. That makes it a hyperbola instead of an ellipse. Make sure your equation's equal to 1. The distance from the center to the vertex, 1, 2, 3 units, squared gives us 9. We went up 3 and down 3, so those are under the y's. Distance from center to focus is 5. So then I can use c squared equals a squared plus b squared to solve for b. b squared is 16, so I can fill that in on my equation here. One ran into my answer box. When we write the equations of the asymptotes, we know that both asymptotes pass through the center. So I'm going to use the point 3,2 as my point. Y minus 3 equals slope times x minus 2. The slope of the asymptote is going to be up 3 and then over 4. Remember, square root of 16 is 4, so we would have gone right 4 from each vertex. Also go left 4 from each vertex. And then you could sketch in your asymptotes. So that slope is up 3 over 4, down 3 over 4, plus or minus 3/4. The last type of problem is one of these where we are asked to change from this big long expanded form into center form, or standard form, so we can identify the center and then graph it. We do it very similar to how we did ellipses. So I'm going to group my x's together, group my y's together, move my constant over. As always, before you complete the square, we need to take out a common factor, in this case a 7. That completing the square rule only works if our a is 1. Here a is -1. We do need to factor out a -1. Complete the square. Distribute 7 times, not 125, 7 times 25. 7 times 25 gives me 175. And I filled in this plus 1. Really, it's -1 times 1. I really subtracted 1 from this side. So subtract 1 from the right. So we've got 7 times x minus 5 squared minus y plus 1 squared equals 49. Dividing both sides by 49 puts it in standard form. And there we go. Last one, if you want to try this one on your own, you certainly can pause the video and try it. We'll do it here in a minute. One thing to note, we can always tell if it is going to be a hyperbola, because we do have both an x squared and a y squared, so it can't be a parabola. If one of them is positive and one of them is negative, that is when it will be a hyperbola. So I'll work through this one here in a minute. If you want to follow along, you can. If you want to pause it and try it on your own and then check it, you can. So we're going to start by grouping our y's together. Y squared minus 4y. The x's, we don't have anything other than the minus 4x squared, and I can add 32 to both sides. Usually we have to factor something out here, but we don't. We don't have to complete the square here. It's already completed because it's just x squared with no x. So all we need to do is add 4 to both sides. Plus 4, there's nothing to distribute or worry about. So this is y minus 2 squared. This is minus 4x squared is equal to 36. Dividing both sides by 36 puts it in standard form. Y minus 2 squared over 36. 4 over 9 reduces to 1 over 9. 4 over 36 reduces to 1 over 9. So the center is at 0, 2. There's my center. A is 6 under the y's, so I go up 6 and down 6. Those are my vertices. Those are at the points 0, 8 and 0, negative 4. C squared. C squared is equal to A squared plus B squared. So C is equal to 3 root 5. We would be going up and down 3 root 5 to get those foci. So we are starting at 0. The y value starts at 2 and goes up and down 3 root 5. To draw our graph, the square root of 9 is 3. Remember, we went up 6 and down 6, so we're going to be going left 3 and right 3 to get the corners of that asymptote box. And then we connect the corners of that box to sketch in our asymptotes. So the graph looks like this. The equations of the asymptotes, they both pass through the center. So y minus 2 equals x minus 0. And our slope is up 6 over 3 or down 6 over 3. Either way, it reduces to 2. Y minus 2 equals plus or minus 2x.